Oxidation is the loss of electrons in an atom. So an oxidizing agent is just a substance that oxidizes other substances. They are commonly used as cleaners and disinfectants, chlorine being a prime example. Reduction is the gaining of electrons in an atom. Therefore, a reducing agent is a substance that reduces another substance. Oxidation and reduction happen simultaneously.
Oxidation occurs when an atom loses electrons. Well, electrons have a negative charge, so when you discuss oxidation and reduction, you have to remember that you're talking about opposites. So, like if an atom went from a -1 to a +4, it's actually losing electrons because it's opposites and electrons have negative charge. So, even though it doesn't really appear, it appears to be gaining because that's what math taught us. Whatever, math doesn't matter anymore. And so vice versa for reduction. So if it goes from like a +4 to -1, it's actually reducing because it's opposites. So yeah.
Okay, in this equation, I'm going to find the oxidizing agents, and I'm going to find which substances are oxidized and reduced. If you take a look here at zinc, you'll notice that it has a 0 charge, because it does not have a 2 negative or a 2 positive. And when it comes over here, it turns into a 2 positive, turning it into the oxidizing, the substance that is oxidized. Because when you gain a charge, that means you are losing electrons. And if you remember, Leo the lion says Gur, oxidized means that you lose electrons. Take a look at the hydrogen. It has a 1 positive. When you see the plus, that generally means 1 positive. When it comes over here, it loses that charge, which means it is being reduced. It goes from a 1 positive down to a 1 negative. Now I'm going to find the oxidizing agents. In the SO4 2 negative, the S is turning into the oxidizing agent because it comes over here and it loses its 2 negative charge and it turns into a neutral charge. So that turns it into the oxidizing agent. The oxygen, also in the problem with the S, is turning into the reducing agent because it is involved with both of those problems, both of those equations, which makes it compounds, which makes it the reducing agent. Okay, in this problem I'm going to do the same thing as I did in the last one. I'm going to find the oxidized and the reduced substances and then find the oxidizing and reducing agents. The I here is the oxidizing, the element that is being oxidized, because it is going from a 1 negative charge over to just a neutral charge. So having it being, it's gaining, and well, it's not gaining, it's losing an electron, which turns it into the oxidized substance. The H is being reduced because it's going from a 1 positive charge to 2 1 negative charges, which means it is gaining electrons, turning it into the reduced substance. Now, the oxidizing agent and the reducing agent are both SO42 negative because SO42 negative is being broken up between the two substances that were reduced, making it both the oxidizing agent and the reduced agent. Okay, again we're going to do the same thing. The oxidized substance is going to be the 2SO42 negative because it is going from the 2 negative charge to a 0 charge, means it is losing its electrons, turning it into the oxidized substance. H is being reduced because it is going from its one positive charge right over here to its one negative, making it reduced. Down here at oxygen, oxygen is the reducing agent because it is splitting this and splitting into all three of different substances, which is what's forcing the H to be reduced. So that is the reducing agent. And C is the oxidizing agent because it is gaining the reducing agent, making it the oxidized agent.
Hello, everybody. We have this equation, 2H, is that right? 2H2 plus O2 yields 2H2O. Okay, so your question is, what's being oxidized and what's being reduced? That's bad handwriting. Okay, to figure this out, we have to figure out the oxidation numbers. Okay, so, and you have a chart on page 186, and you also have a set of rules, and one of those rules is that if you have a free element, it's an automatic 0. So, hydrogen and oxygen are alone, so they have a 0 for an oxidation number. Okay, on your chart, page 186, you'll figure this out. Hydrogen can either be a positive 1 or a negative 1, and oxygen can either be a negative 1 or a negative 2. But when you do this, it all has to balance out. So 2 times 2 times that number, and then 2 times this. So when it all works out, 2 times 2 times a positive 1 is going to give you a positive 4. And you're going to have a negative 2 over here because 2, you want to make it equal 0. You're balancing. So, that's so bad. Anyway, so this all balances out. Actually, it's going to be a negative 4. So, when you're talking, you have to remember, Leo the lion says grr. Okay, which means losing electrons you're oxidized, gaining electrons you reduce. So, and you're talking about electrons, and electrons have a negative charge, so you're talking with the opposite. So, if it looks like you're gaining from a negative to a positive, you're actually losing. So, we went from a 0 to a positive 4, which means that hydrogen was being oxidized, and we went from a 0 to a negative 4, which means that oxygen was being reduced. So, okay. So, we're going to figure out what's oxidized and reduced again. So, in order to do that, we have to figure out our oxidation numbers. And silver, right here, has a positive 1 charge. And nitrogen has a positive 2. So with this guy, we're going to have to balance it out. This is, altogether, it's positive 3. And so, like I said before, oxygen can either be a negative 1 or negative 2, but you have to multiply it. And so 3, so you obviously don't want 2 because you have a negative 6. Altogether, you're going to have a negative 1 for your oxygen. Okay. So, copper, because it's a freestanding element, it's going to have a 0. It's neutral right now. So when it yields, copper is going to then have a positive 1. Nitrogen is going to have a positive 2. And oxygen is again going to be a negative 1. And this is going to be 0. This silver right here. So, like we said before, it's opposites. So you can see there are things that remain the same, right? So, you see that nitrogen has the same thing, so he's not either 1, right? Oxygen has the same thing, he's neither 1. So you're left with copper and silver, and you can see that Copper is being oxidized because it went from a 0 to +1, and it's opposite, so it's actually losing. And silver is being reduced because it's opposite and it's gaining. Okay, we're going to find the oxidized and reduced element in this. So we have to assign oxidation numbers. So you have 2 PBS. I remember everything is multiplied by 2. So your PB is going to have a +2, and your S is going to have a -2, balancing it. And your oxygen right here is a free element, so it's going to have a 0. And then you're going to your your S right here is going to have a +2, and your oxygen is going to have a -1. And like I said, page 186. And it's real easy to do. You just balance. And then over here, you're going to have 2 PB with a +2 right here. And oxygen is going to be -2. Okay, so what's been oxidized? Can I still see it? Okay. And what has been reduced? Okay. So, if you look here, sorry, your PEB has the same oxidation number on both sides, so it's neither one. But your oxygen went from a 0 to a -2, so you're actually gaining electrons. So your oxygen is being reduced. And your sulfur went from a -2 to a +2. And so you actually lost there, and your sulfur is what has been oxidized. Second. That's not cool. Okay, we're going to balance. We're going to balance this equation using the oxidation number method. And Gregory's going to be my hand because he was too stubborn to move. Okay, so we have this equation. SO2 plus Br2 plus H2O yields HBr plus H2SO4. And it's going to end up being, so write this down, brother. SO2 plus Br2 plus 2H2O yields 2HBr plus 2H2SO4. Thanks, Greg.
Okay, in this equation, we are going to balance it using the oxidation number method. So it will end up being 5CO plus I2O5 yields I2 plus 5CO2.